Well, in this first special video, I'd like to talk about the chain rule. You recall that if we have y is equal to some function of x, and you know the derivative y prime equals dy dx equals f prime of x, and we know a whole lot of functions and their derivatives. For instance, we know that if y is equal to 21 x to the third power, that y prime is equal to 63x squared. If we have that y is equal to sine of x, we know that y prime equals cosine of x. Just straightforward. We've done a lot of derivatives. If we have y is equal to the square root of x, we can write that as x to the 1/2 power, and we know that y prime is equal to 1/2 x to the minus 1/2 power is equal to 1 over 2 times the square root of x. And one more simple example, if y is equal to the tangent of x, we know that y prime equals secant squared of x. But suppose that y is a little more complicated. Suppose y is equal to some function of g of x. In other words, it's not just x. Well, the strategy we use is to use a substitution and let y equal to g of x. In fact, you can do this really in your mind and not actually put down u. And the chain rule says that dy dx equal y prime of x is equal to dy du times du dx, the chain rule. Something that's not hard to implement, but it's also something that's easy to forget sometimes. So let's take a simple example. Suppose y is equal to 2x minus 7 to the third power. We would let this inner function, since it's not plain old x, call it u. And then we would calculate dy dx equal y prime of x equals 3 times 2x minus 7 to the second power. But then we have to multiply by du dx, which is 2. Simplifying this, we get 6 times 2x minus 7 squared. That's a very simple example. Let's take another example. Suppose we had y equals 9x squared plus 4 to the 1/3 power. Again, this is not plain old x, so we'll call it u and take dy dx is equal to 1/3 times 9x squared plus 4 to the minus 2/3, and then multiply it by du dx. In fact, you don't have to really write all this down, but du dx will be 18x. And simplifying this will give you 6x, and bringing the numerator down to the bottom and changing its exponent to a positive number, we get 9x squared plus 4 to the 2/3 power. Another example, suppose y equals 1 over x plus the square root of cosine of x. And let's rewrite that as x to the minus 1 power plus cosine of x to the 1/2 power. Taking the derivative of each of these components separately, the derivative of the first term will be minus 1 times x to the minus 2 plus the derivative of the second term, the cosine of x to the 1/2. We have to use a chain rule, which means we'll take 1/2 cosine of x to the minus 1/2 power. But we have to multiply it by the derivative of cosine of x, which is minus sine of x. Simplifying this, we get minus 1 over x squared. We're going to have a negative sign here, so we're going to have a minus. Let's leave the sine of x on top. And since this is a negative exponent, let's bring it down to the bottom and make it the square root of cosine of x. So that's another example of using the chain rule. Do one last example. Let's take y equals x divided by the square root of x squared plus 1. Here I would rewrite this as x times x squared plus 1 to the minus 1/2. And we're going to start off thinking about the product rule. So let's calculate this. Y prime is equal to the first times the derivative of the second one. Now here again we have to use a chain rule. We have an inner function u. So we take the power, put it out in front, take x squared plus 1 to the minus 3/2 power. But we're not through, because we have to take the derivative of this u, which is 2x. Then to complete the process, we have to complete the product rule, which would be the second, which is x squared plus 1 to the minus 1/2 times 1. And this equals, canceling out our 2 here, we're going to have minus x squared times x squared plus 1 to the minus 3/2 plus x squared plus 1 to the minus 1/2. And if you simplify this, you get minus x squared over x squared plus 1 to the 3/2 power plus 1 over x squared plus 1 to the 1/2 power. If we want to simplify this even further, we write this as minus x squared divided by x squared plus 1 to the 3/2 power. And to have the same denominator, we just multiply the top and the bottom by x squared plus 1. And so on the bottom we would have x squared plus 1 to the 3/2, just like the other term. So since we have the same denominator, we can now add. And this problem was sort of made up, I suspect, because now notice you can add the x squared and the minus x squared and get 0. And this simplifies to 1 over x squared plus 1 to the 3 hash power.